Hi, in this video we'll do a couple of examples of how to integrate an exponential when we have a base other than e. So our general rule is that the integral of a raised to the x power dx is 1 over natural log a to the x plus c. So applying this, we can do a couple of examples. In this first example, I'm adding two things, so recall that I can write this as the integral of x squared dx plus the integral of 2 to the minus x dx. So I can integrate each one separately. The integral of x squared, well, that hasn't changed. That's just x cubed over 3. And now I'm going to apply my rule above to integrate 2 to the minus x. Now, the key here is that I have to have the derivative of my exponent here, minus x. The derivative of minus x is minus 1, so I need to put a minus 1 out here, and then I need to have a minus 1 out here as well so that I don't change it. And now when I get ready to integrate this, it's going to be 1, all right, but I have the negative, so it's going to be minus 1 over natural log of a. A in this case is what the base of my exponent, which is 2, so natural log of 2. Right, times a to the x, which again is just what I just had, 2 to the minus x, then plus my constant. So I'm adding this as well. All right, so my final answer would be that a cubed over 3. This is a negative, so I can subtract 1 over the natural log of 2 to the minus x. And I could put my 2 to the minus x down here as well, since that's a negative exponent. In other words, I could also write this 1 natural log 2 to the x plus c. Right? Here's another example. In this example, again, I need to have the derivative of my exponent, and this time it's minus x squared is my exponent, so my derivative is going to be minus 2x, so I need to put a minus 2 here, along with my dx gives me my derivative, but because I put a minus 2, I need to put a minus 1/2 so I don't change the problem. So now I have minus 1/2, the integral of 5 to the minus x squared, and then minus 2x dx, which again is my derivative. When I integrate this, I can just apply the rule above. I get minus 1/2, and now the integral of 5 to the minus x squared is 1 over the natural log of my base, which is natural log 5. Okay, and then 5 to the minus x squared, and then I'm going to add my constant. Again, I can rewrite this as negative. I get 1, 2, natural log 5. All right, and if I wanted to, I could put 5x squared down here. Okay, whichever way, plus my constant. One more example. In this example, again, I have definite integral. I am wanting to evaluate this from 0 to 1. So I'm going to first integrate it, and then I'm going to do the evaluation. Again, I'm subtracting here, so this is going to be equal to the integral 0 to 1, 5 to the x dx. Subtract the integral 0 to 1, 3 to the x dx. Okay, and now once again, my rule's up here. I don't have to worry about my derivative because the derivative of my exponent in this case is just 1, which I already have. So then I'm just going to apply this. It's going to be 1 over natural log 5 to the x, right? And I need to evaluate that at 0 and 1. And then I'm subtracting the same thing, 1 over natural log 3, right? 3 to the x, and then I guess I should really write this. I'm going to evaluate this whole thing at 1 and 0. Okay, right. So first I'm going to plug in my 1. If I plug in 1, I get a 5 here. So this becomes 5 natural log 5, and then I'm going to subtract. If I put a 1 in, I get a 1 here. So this is going to be 3 natural log 3, and now I'm going to put in the 0. The 0, any number raised to the 0 power becomes 1, so that's going to go away. So I'm going to have subtract, okay, because remember it's this minus this when we evaluate it, 1 over natural log 5. The 5 of the x has gone away because it became 1 when I plugged in the 0. And now it's going to be minus a minus, so this is going to become a positive. Again, when I plug in the 0 here, this goes to 1, and I get 1 over natural log 3. And now I can combine these. The 5 over natural log 5 minus 1 over natural log 5 just becomes 4 over natural log 5. And here I've got negative 3 natural log 3 plus 1 natural log 3, so that becomes minus 2 natural log 3. So that would be my final answer. Hope these examples help. Let me know if you have questions.